Okay, welcome back. Today we're going to be doing Logic-1, of course. In this section, we're basically just going to be using like if-else statements and some Boolean operators. We've talked about and or, and negation here. Whenever you see logic in programming, that's referring to like these sorts of things. So hopefully this section should be pretty straightforward, relaxing, not too difficult. Um, So let's get started. When squirrels get together for a party, they like to have cigars, as we all know. A squirrel party is successful when the number of cigars is between 40 and 60 inclusive, unless it is the weekend, in which case there is no upper bound on the number of cigars. Return true if the party was successful, or false otherwise. Go ahead and pause and try this. Alright, so I'm just going to split this into two cases, if it is the weekend and if it is not the weekend. So, if it is the weekend, then I just need to return true if the number of cigars is at least 40, because there's no upper bound. And then otherwise, I'm going to return if the number of cigars is between 40 and 60. And so the way we can do that is we can just say cigars is greater than or equal to 40 and it's less than or equal to 60. That'll be this here. What I just highlighted will be true if cigars is between 40 and 60 inclusive. Sometimes I write this as, I just like reverse the order. I say 40 less than or equal to the number of cigars. And I just like this better because in math, if you want to say like x is between 3 and 5, we'd say like 3 less than x less than 5. And so this looks a little more like that. You may have tried doing this already and noticing that it does not work. Um, so yeah, I sometimes do it this way because I think it's kind of clearer that we're saying, because like cigars is physically between the 40 and the 60, and we want the number to be between 40 and 60. Um, so of course we could get rid of those curly braces, and if we wanted to do this all in one line, we could do that as well. So I'll show you how to do that, or in one statement, I should say. So let's do that as well. So basically, if it is the weekend, we um, sorry, I guess let me rephrase the question. So if it is the weekend and the cigars is greater than or equal to 40, then we had a successful party. Or if it's not the weekend and the cigars is between 40 and 60, then the party is successful. So I'm going to basically just put what I just said into code. So I return true if it is the weekend and the number of cigars is greater than or equal to 40. So that's one case. I'm going to put it in parentheses. So that's one way in which the party can be successful. Or the party is also successful if it is not the weekend and the number of cigars is between 40 and 60. So if I put a semicolon on there, this is another way to do this all in one statement. And the reason I like to say one statement instead of one line is because, you know, again, white space doesn't matter, so I could put, any amount of enters I want, or delete any amount of enters I wanted to, and it'd still be equivalent. So, yeah, that is how we could do this way, or this problem. Another way to split up the logic would be, and by the way, I won't spend this much time with every other problem, but another way to split up the logic would be to first test if the number of cigars is greater than or equal to 40. Then, if it is a weekend, we return, if we just return true actually. And then otherwise, we return if the number of cigars is less than or equal to 60. And then otherwise, we return false. So that's another way of splitting up the logic. If you were to write this more concisely, it might look like return cigars greater than or equal to 40, and either it is the weekend or the number of cigars is less than or equal to 60. So that as another way to write it, which I think is, yeah, this is actually much more compact than we had before. Um, so yeah, that is how we could do this one. And I think what I have here would probably be the most elegant, best solution, I would say. But, you know, what's the best solution is kind of subjective, kind of not. Okay, so you and your data are trying to get a table at a restaurant. The parameter u is the stylishness of your clothes in the range 0 to 10, and date is the stylishness of your date's clothes. The result, getting the table, is encoded as an int value with 0 equals no, no, 1 equals maybe, 2 equals yes. Sorry, I really can't read today. If either of you is very stylish, 8 or more, then the result is 2, yes, with the exception that if either of you has a style 2 or less, the result is 0, no. Otherwise, the result is 1, maybe. Go ahead and pause and try this. All right, so basically this rule that if either of you has a style 2 or less, the result is no. That rule trumps all the other rules, so if u is less than or equal to 2 or date is less than or equal to 2, you return 0 for no. And then otherwise, if either of you is very stylish, so or is greater than or equal to 8, we return 2. Otherwise, we return 1. So that is how we did it. They did it pretty much the same way. Okay, so I will show you something here that I've been tempted to show you this whole time, but I haven't yet done it. So I want to show you something called the ternary operator. So again, that is the ternary operator. And it's called the ternary operator because it's the only operator that has 3 things. So like addition, right? There's one thing on the left side and one thing on the right side. So there's 2 operands. But the ternary operator has 3 operands. And basically, here's how it works. It's basically like an inline if statement. So let's ignore this top part. We're just going to leave this top part as is. But let's consider this bottom part, right? So this whole thing that I've highlighted, including the return 1 at the bottom. So if u is greater than or equal to date, or date is greater than or equal to, it's greater than or equal to 8, or date is greater than or equal to 8, then we want to return 2. Otherwise, we want to return 1, right? That would be a accurate assessment or summary of this code. So basically, what we can do is we can say, I'm going to type return, and then inside these parentheses are not necessary, but I'm just doing them to show you something. Inside these parentheses, I'm going to use the ternary operator to put this all into one line. So basically what you do to use the ternary operator is the first operand is a Boolean expression, so a Boolean condition, and I'm going to put this condition right here. Okay, so that's my first operand, and then what you put after that is a question mark, and then the second operand is what you want the value of your ternary expression, which is this whole thing in parentheses. So after this question mark, the second operand is what you want the value to be if the condition is true. So in this case, if this condition is true, we should be returning 2. So 2 is what we return if it's true. And if it's false, or in other words, otherwise, we want to return this value, 1. So I'm going to put a colon and then 1. So 3 operands. First one, Boolean expression, and then something, and then something else. And the first thing is what you return, or what the value is if it's true. Second is what the value is if it's false. So this will also do the problem, and as I said, parentheses there, not required. So that's how we could do this. If you really wanted to, you could nest the ternary operator. That's getting a little too confusing for now, so I won't. But that is basically the ternary operator. Now, does this make your code clear and easy to read? Yeah, maybe not. So should you be using the ternary operator everywhere? Perhaps not. But I do want to tell you about it so that you know. All right, the squirrels in Palo Alto spend most of the day playing. In particular, they play if the temperature is between 60 and 90 inclusive. Unless it's summer, then the upper limit is 100 instead of 90. Given an int temperature and boolean is summer, return true if the squirrels play and false otherwise. Go ahead and pause and try this. You can do it in one statement. Alright, so I'm going to split it up into two cases first, and then I'll show you how to do it in one statement. So if it's summer, then you return if the temp is between 60 and 100. Otherwise, we return if the temp is between 60 and 90. Alright, there you go. And if you wanted to do this in one line, basically what we're doing is we're going to either return true if it is summer and the temperature is in this range. That's one possibility. Or I'm just going to indent things so they line up. Or it is not summer, and this condition is true here. Okay. So that is how we could do this one. I'm trying to think logically if there's any way to simplify this. Because, let's see, so let's see, if this thing is false, we don't know the value of is summer, so we do need to check it again here, I think. It's been a while since I took like a logic class, so I don't exactly remember. But yeah, so I mean this obviously does work. I'm just looking to see if there's a way to simplify this. So yeah, that's one way to do it. Another way to do it is kind of like we did the cigars one, to first check if it's first check if 60 is less than or equal to the temperature, and I'm actually going to rewrite that as temperature greater than or equal to 60, and either it is summer and the temperature is less than 100, or it's not summer and the temperature is less than or equal to 90. So that, is summer. That would be another way of doing it there. And let's see, let me think if I can simplify this real quick. So I've thought about it, and I think that we can simplify it just a little bit. So another way of writing this, let me put this on the second line, is to say return that the temperature is greater than or equal to 60, and either the temperature is, I'm going to put this again on a new thing here, and either the temperature is less than or equal to 90, or it's summer and the temperature is less than or equal to 100. And because of operator precedence, we're going to need some parentheses there. And we're going to need to comment that out before it will compile. But yeah, this is another way to do it there. And that actually does fit on one line. So yeah, a lot of ways to do things here. Yeah, I think that is all I want to talk about with this one. Alright, you are driving a little too fast and a police officer stops you. Write code to compute the result, encoded as an int value. 0 is no ticket, 1 is small ticket, 2 is big ticket. If speed is 60 or less, the result is 0. If speed is between 61 and 80, the result is 1. If speed is 81 or more, the result is 2. Unless it's your birthday, on that day, your speed can be 5 higher in all cases. Okay, so go ahead and pause and try this. Okay, so there are a bunch of ways to do this. I'm going to go over a way that's perhaps not the most immediately obvious way. So what I'm going to do is I'm going to get the bound. So basically, there are two important numbers when we're we're doing this problem. Let's ignore the birthday part for a second, ignore this sentence. But the two important numbers are 60, because that's the threshold between no ticket and getting a small ticket, and then 80, because that's the threshold between a small ticket and a big ticket. So I'm going to create two variables. I'm going to call it low threshold and high threshold, or I'll just say low. I'll say low and high. And basically, I'm going to assign the values to these thresholds, right? Because if it's your birthday, these thresholds are going to be 5 higher in both cases. So what I'm going to do is I'm going to assign low and high based on whether or not it is your birthday. So if it is your birthday, then low is going to equal 65, and high is going to equal 85. And then otherwise, low is going to equal 60, and high is going to equal 80. There's a perhaps more concise way of doing that, which I'll show you in just a second. But now that I have the two thresholds, all I need to do is check the value of speed against these thresholds. So if speed is less than the low threshold, you get no ticket. If speed is, if speed is between the low ticket, and by the way, this is, let's see, this is inclusive. If, your speed is between the low threshold, low less than 60. Alright, low, CodingBat is not letting me type. It is, okay, it's just not letting me type. I'm gonna refresh. Okay, can I type now? Can I type anywhere? Yes, I can. Okay, now it's gonna let me type apparently. Okay, sorry about that. So if your speed is between the low threshold and the, your speed is between the low threshold and the high threshold, then we can return 1. What are you doing, CodingBat? It's not letting me go down. Okay. Then we return 1, otherwise you get a big ticket. And then, what did I do? Higher. There we go. So that's how we could do this. One way to shorten the top part is to first assign them each to their values that they would be if it's not your birthday. And then if it is your birthday, only then do we change them. We're basically assuming that it's not your birthday, and then we're checking if it is your birthday and we modify things. Another way of saying this is we could also say high plus equals 5, like we're adding 5 to both the low and the high thresholds there. So that's how we could do this one. And you might have thought of a different way to do this. One way is to first have like an if is birthday, and then have like this kind of thing within here, and then have an otherwise it's not your birthday, and then you have again this kind of thing in here. So that, and this is another kind of way to do this. Obviously this is not correct as it stands now, but this is another idea of how to do this. So yeah, that is this one. Given two ints, a and b, return their sum. However, sums in the range 10 to 19 inclusive are forbidden, so in that case just return 20. Go ahead and pause and try this. Okay, let's go ahead and do this one. So sums in the range 10 to 19 are forbidden. Okay, so I'm going to first get their sum, a plus b, and then if their sum is in the range 10 to 19, then we return 20, otherwise we return their sum just regularly. There we go. If you wanted to use ternary business here, we could do that. Return, if it's in that range, we do 20, otherwise just the sum. That is another way of doing this. If you really wanted to, you could put this all into one line like that, but I think that's just unnecessary. Okay, so that's how we could do this one. They did it pretty much the same. Given a day of the week encoded as 0 equals Sunday, 1 equals Monday, etc., and a Boolean indicating if we are on vacation, return a string of the form 7 o'clock, indicating when the alarm clock should ring. Weekdays, the alarm should be 7 o'clock, and on the weekend it should be 10 o'clock unless we're on vacation. Then on weekdays it should be 10 o'clock, and on weekends it should be off. So go ahead and reread that one if you need to. I know I will. But go ahead and pause and try this. Okay, so let's see. So weekends are going to be when day is 0 or 6. So what I'm going to do is I'm just going to have a Boolean. Boolean is weekend. Takes the day and it's going to return true if day is 0 or the day is 6. So that is going to mean it's a weekend. And I talked to you, I think, about how you don't need to put public on here. You can if you want to, but you don't need to. So I'm just going to omit it. Um, okay, so this will tell me if I'm on a weekend. So basically now it says if we are on vacation versus not vacation, then we're going to have different behavior. So I'm going to split it up like that. So if we're on vacation, um, then let's see. Then we should return 10 o'clock on weekdays, and weekends we should return off. So if it is, in fact, I'm just going to actually go straight to the ternary here. So if it is a weekend, then we are going to be, the alarm's going to be off. Otherwise, it's going to be at 10 o'clock. And then otherwise, if we're not on vacation, then if it is a weekend, then we wake up at 10. Otherwise, we wake up at 7. That is how we could do that if I could spell right. Okay, so of course we can omit these curly braces, and that is how we could do this one. Um, I think the isWeekend method, right? Because you could argue that writing the isWeekend method doesn't actually shorten your code, right? In fact, it even makes your code longer. Um, but I think it's actually good to write it because again, it makes your code clearer and easier. Like this is way easier, right? Just saying day equals 0 or day equals 6 is not very clear what that means. But if I, you know, put that code in a box and I call that box isWeekend, then it's very clear what that means. So yeah, that is how we could do this one. I know I kind of wrote the code in the reverse order it gave the directions. Like it told us about what to do on vacation afterwards, but I did that first in my code. And that's just because generally in if statements, like I like to do the positive case first. And by that I mean like the Boolean where I don't have to negate it. Because like if I wanted to talk about the non-vacation situation first, I would do like if not vacation. And if I wanted to talk about the case where it's not a weekend first, where it's a weekday first, I'd have to do not weekend, not is weekend. And I generally just like to do the the case where I don't have to negate anything first, and then else will be what the negated case would be. So yeah, that is how we could do this one. The number 6 is a truly great number. Given two int values a and b, return true if either one is 6 or if their sum or difference is 6. Know the function math.abs, which you already know about, computes the absolute value of a number. Or I believe you already know about that one. You might have talked about it before. Okay, so go ahead and pause and try this. Alright, so this can all be done in one expression, one single statement, and I'm just going to jump straight to that. So we're going to return true if A is 6, or B is 6, or their sum is 6, or their difference. Math.abs A minus B, that'll give you the difference between two numbers. Actually, now that I think about it, I think we have talked about that. Or their difference is 6. There we go. So yeah, taking the absolute value of A minus B will give you a positive number indicating the distance between A and B. That's sort of a mathematical thing. So this is a very common, idiom to determine the distance between two numbers. And that will solve that one. Given a number n, return true if n is in the range 1 to 10, unless outside mode is true, in which case return true if the number is less than or equal to 1 or greater or equal to 10. Okay, so unfortunately these two, actually wait, before I go into that, pause and try this one, please. Okay, now I can talk about it. So unfortunately these two possibilities one where n is in the range 1 to 10 inclusive, and then the other where n is less than or equal to 1 or greater than or equal to 10. These cases are not exactly opposites, right? In order for them to be opposites, this would have to be if the number is strictly less than 1 or strictly greater than 10. So if they were exact opposites, this code would be a bit easier, but they're not. So I'm just going to split it up based on the value of outside mode. So if we're in outside mode, then we need to return if n is less than or equal to 1 or greater than or equal to 10. Otherwise, we return if n is between 1 and 10 inclusive. All right. Let's see, what have I done? Sorry, and would be a bit better. All right. Of course, we can just clean that up as well. All right, moving on. We'll say a number is special if it is a multiple of 11, or if it is one more than a multiple of 11. Return true if the given non-negative number is special. Use the mod operator. I've done a lot of like teaching comp sci, so I can't exactly remember what we've talked about in this series and what we haven't. But I'll tell you about mod right now, but if you already know, please skip this part. So mod, basically all it does, just a short description, is it finds the remainder if you were to divide two numbers. So if you do 7 mod 2, the result will be 1, because if you were to divide 7 by 2 by hand, like do long division, the remainder you'd get would be 1. So 7 mod 2 is 1, like 8 mod 2 is 0, 9 mod 2 would be 1. Like 13 mod 11 would be 2, since the remainder there would be 2. And that's basically what the remainder operator does. It is not called the mod operator. CodingBat gets it wrong here. So it's actually technically called the remainder operator. Mod is short for modulus, and that's something different in math, but they're very, very similar. So yeah. All right. So now go ahead and pause the video and try this. All right, let's do it. So if a number is a multiple of 11, then its remainder when dividing by 11 is going to be 0. So we need to return true if n mod 11 is 0. That means, in other words, if n is a multiple of 11, or it is 1 more than a multiple of 11. So let's think about this, right? Any number that's 1 more than a multiple of 11, like 12 or 23 or 34 or 45, these numbers, if we were to mod them by 11, are going to have the value 1 because the remainder when you divide by 11 is 1. So I can say return if n mod 11 is 0 or n mod 11 is 1. Oops. Then we could do that here. And notice that the remainder, since we know actually, let's see, yeah, we're assuming that, or no, so sorry, we don't have to assume because it tells us the given number n is non-negative. And so if you use negative numbers with the remainder operator, it gets a little interesting, like with what the sign of the result is going to be. But fortunately, we don't have to worry about negative numbers here. So what that means is that when we're modding a non-negative number by a non-negative number, the result will always be another non-negative number. And so what that means is that the result of n mod 11 will never be less than 0. And therefore, we can simplify this to say instead, return n mod 11 is less than or equal to 1. Because the only value in mod 11 could be if it's less than or equal to 1 is 0 or 1. So a very nice, small, tiny solution there. Return true if the given non-negative number is 1 or 2 more than a multiple of 20. See also Introduction to Mod. Okay, so go ahead and pause and try this. Okay, so 1 or 2 more than a multiple of 20. Notice that it can't be a multiple of 20. It has to be 1 or 2 more than a multiple of 20. So to do this, we know that if it is 1 more than a multiple of 20, then in mod 20 is going to be 1. If it's 2 more than a multiple of 20, in mod 20 is going to be 2. So very straightforwardly, we will write this code. So in mod 20 is 1, or in mod 20 is 2. There we have it. Return true if the given non-negative number is a multiple of 3 or 5, but not both. Whenever you see but not both, when you say like x or y but not both, there's a special operator which we talked about long ago that you should be thinking about. Use the mod operator. Go ahead and pause and try this. Okay, so that special operator I mentioned is this one. It's called XOR, short for exclusive OR, which is basically saying A or B, but not both. It's exclusive of like of the possibility that you could have both. So it's one or the other, but not both, and that's exactly what this question is asking for. So I'm going to do that. So I'm going to just create Boolean variables here. We can write this concisely all in one statement later, but I'm going to just create Boolean variables to store if it is a multiple of 3 and if it's a multiple of 5. So sorry, not in variables. It's a multiple of 3 if in mod 3 is 0, and it's a multiple of 5 if in mod 3 is 0. And here it is very important to, sorry, mod 5 is 0. It's very important to know the difference between these two things, equals versus equals equals. Okay, so now I know if it's a multiple of 3 or multiple of 5. So if you didn't know about the XOR operator, the way you'd have to do this, the most concise way of doing this, we want to know if it is a multiple of 3 or 5, but not both. You'd have to say return if it is a multiple of 3 and not a multiple of 5, or it's a multiple of, or it's not a multiple of 3 and it is a multiple of 5. So that is how we would do that one. However, we have a special operator called the XOR operator that does this, but more concisely. So another way of writing that is saying return mult3 XOR mult5. This is basically saying return true if either mult3 or mult5 is true, but not both. So if you want to think mathematically, this is like an identity that we've just found. This here is equivalent logically to this. So that's a Boolean identity. So there you go. If we wanted to, we could put this all into one statement like this, and I'm going to actually check the operator precedence table to see if I need parentheses here. So let's see, mod I know comes very high right there, but then does equals equals come between this and XOR? So yeah, then equals equals is going to come next, and then XOR. So it looks like this will still be evaluated as I want it to. So yeah, there you go. And now I no longer need these variables. So another deceptively concise solution here. Okay, return true if the given non-negative number is 1 or 2 less than a multiple of 20. So for example, 38 and 39 return true, but 40 returns false. Pause and try this. Alright, so pretty much just like the other ones, if a number is less than, sorry, is 1 or 2 less than a multiple of 20, then if we were to mod it by 20, the remainder should be 18 or 19, right? Because 38 mod 20 is 18, 39 mod 20 is 19, and of course 40 mod 20 is 0. So we need the remainder to be of in mod 20 to, and yeah, sorry I keep saying mod. Even I've heard this percent sign called mod so many times that I sometimes just without thinking call it mod. It is technically not called mod, just so that we're clear. It's called the remainder operator. So in remainder 20 should be 18, or in remainder 20 should be 19. Then it will be 1 or 2 less than a multiple of 20. You can think logically about how I know that in remainder 20, will never be equal to 20 or greater than 20. So I can do this as well. And that will also solve it, because I know if in remainder 20 is greater than or equal to 18, that in remainder 20 must either be 18 or 19. It can't be anything else. So there you go. Given a non-negative number num, return true if num is within 2 of a multiple of 10. Okay, so go ahead and pause and try this. All right, so let's see here. How should we do this? There's obviously an obvious way. I'm just thinking if there's a clever solution, and I cannot think of one right now. So here's how we could do this. So if it is 2 away, or sorry, within 2 of a multiple of 10, then either I'm going to split that into two cases. Either it's 1 or 2 above 10, or it's 1 or 2 below 10. And we know how to find either of those cases. So we need to return true if either, I'm going to put each, branch in parentheses. So we need to return true if either num is 1 greater than a multiple of 10. So it is, if actually, and because it says within 2 of a multiple of 10, we actually also want to include multiples of 10. So we also need to handle the possibility that num might just be a multiple of 10. So in other words, num mod 10 equals 0. So I'm actually just going to say here, num mod 10 is less than or equal to 2. So this will handle cases where num is a multiple of 10, where num is 1 more than a multiple of 10, and where num is 2 more than a multiple of 10. And then we want to know if num is less than a multiple of 10. So I'm going to say num remainder 10. I'm trying to like consciously remind myself to always say remainder and not mod. Or num mod 10 is 8 and num mod 10, or num mod 10 is 9. And that'll work. Hopefully you're already seeing that I could simplify this as num mod 10, remainder 10 greater than or equal to 8. There we go. That is how we could do this one. I believe the Boolean, let's see, does the Boolean stuff come first? No, it doesn't. So it looks like I don't need these parentheses. The operator precedence is how we would like it here. So very nice. All right, given two ints, a and b, return their sum. However, teen values in the range 13 and 19 inclusive are extra lucky. So if either value is a teen, just return 19. Go ahead and pause and try this. Because I just love my helper method so much, I'm going to write a helper method is teen int x, return, let's see, 13 less than x, and there's the and, x is less than or equal to 19, so I need to return, so if a is a teen, or b is a teen, then I return just 19, otherwise I return their sum. So there we have it there. We could use ternaries here, or the ternary operator. That was actually my first thought, and then I went and did it with if statements instead. So this is also how we could do this one. So again, of course you could write this all in one statement without the helper method, but I think the helper method makes it clearer and easier to think about. So there you go. Your cell phone rings. Return true if you should answer it. Normally you answer, except in the morning when you only answer if it's your mom calling. In all cases, if you are asleep, you do not answer. So, pause and try this. I'm going to turn down the editor size here so we can see everything. Okay, so if you are, I'm just going to do this with if statements, and maybe we can see if we can simplify it later. But if you're asleep, all right, return false. It says in all cases, return false if you are asleep. So that rule trumps everything else, so I usually put that first. Okay, and then otherwise, we return true. We say if it's in the morning, then we only return true if it's mom that's calling. So if is mom, return true, otherwise return false. Hopefully you are seeing a way to simplify this. We could rewrite this as just return is mom, and then otherwise we return true. Otherwise we just answer it. So there you go. We can delete these curly braces. So not too long of a solution, but we can still uh, perhaps make it better. So let's ignore the first if statement, if is asleep, and let's just think about how we could simplify this part here. So basically what this is saying is that if it is morning and it's mom, return true. Actually, let me rephrase this. So if it's not morning, then we just return true. Otherwise, otherwise we know that it is morning, and we only return true if it is mom. So what we could do is we could say return either it's not morning, because if it's not morning, we answer, right? We already know that we're not asleep, so if it's not morning, we answer. So return either it's not morning, or it is morning and it is mom. So that is how we could simplify that. And again, the operator precedence is going to make sure that this and part is evaluated first. Okay, and now let's see if we could simplify this further. So another condition, in addition to this being true, another condition in order for us to return true is that we're not asleep. So I'm just going to basically tag that on here and say, if we're not asleep and this is satisfied, then we're going to be good here. And let's see, it looks like we do need the parentheses here, because if we deleted them, it would not work. We need the parentheses here. So yeah, that is how we could do this one. Again, we've simplified it, we've boiled it down to just a single statement, which is wonderful. All right, I'm going to redo my editor here. Okay. We are having a party with amounts of tea and candy. Return the int outcome of the party encoded as 0 is bad, 1 is good, 2 is great. A party is good if both tea and candy are at least 5. However, if either candy is at least double the amount of the other one, their party is great. However, in all cases, if either tea or candy is less than 5, the party is always bad. Pause and try this one. Okay, so whenever I see something that says like in all cases, then I like to just put that first and get that out of the way, because I know that trumps every other rule. So it says, in all cases, if tea or candy is less than 5, the party is bad. I'm just going to say return 0. This is too close for me. I need to zoom out. Okay, so we return 0. And then what we say is, so if either tea or candy is at least double the amount of the other one, so I'm going to write that here. So if tea is double candy, so if tea is at least double candy, so candy times 2, or candy is at least tea times 2, then I'm going to return 2 because it's great. Otherwise, 1. There we go. We could, of course, simplify this using ternary. I guess not really simplify, but we could make it more concise using ternaries if you really wanted to, but I think this will be fine. Given a string stir, if the string starts with F, return fizz. If the string starts with B, return buzz. If both the F and B ends with B, return buzz. If both the F and B conditions are true, return fizz buzz. In all other cases, return the string unchanged. Pause and try this. All right, let's go. So let's see here. We could just split this up into 4 cases, right? One, it starts with F but does not end with B. Sorry, the other case is if it ends with B and does not start with F. Another case is if it starts with F and ends with B. And the last case is it does not start with F, nor does it end with B. We can split it up into 4 cases. And I'll write that first, but maybe we can simplify it after. So I'm gonna do them in a different order than I said them, but I'm still gonna do the same things I said. So um, it starts with F or starts with F and ends with F. Ends with B. Then I return is buzz. Else if it starts with, and I actually don't need the else because I know that if I enter this if statement, I'm returning, so I'm not going to execute anything else anyway. So if the string starts with F and does not end with B, I'm going to return fizz, and then I'm going to, if it does not start with F and does start with B, end with B, then I'm going to return buzz. Otherwise, it says return the string unchanged. So there we go. All right. Let's think about possibly how we could solve this, or sorry, how we could do this a bit differently. So here's another idea that comes to mind. We could do a result string, start it out as empty. We could say if stir starts with F, we add fizz to the result. If it ends with F, ends with B, we add buzz to the string, and then down here we say if the result is empty, right? So if we ended up not adding anything, if the result is still this empty string, then we know it didn't start with F nor end with B, so we return actually just the given string and don't even use result. Otherwise, we return result, and that will do that one. Of course, we don't need this else here. And we could do this with a ternary if we really wanted to. If it's empty, we return stir, otherwise result. So there we have it. That is another way to do this one. Let's see how they did it. Yeah, so they did it how I did it here. They made it a little simpler than I did. So I explicitly wrote out all the cases, but they noticed that you don't need, if I go back to my code here, let me comment out this top part. Here and go back to the bottom part. So they notice that if both these conditions are true, I'm just going to call them F and B because this way they write it here is a lot more compact. So if F and B are true, right, then I'm going to enter this if statement, right? But if I get past that if statement, if I get to where my cursor is here, I know that either one or both of the conditions are false. I know either F is false or B is false, or both of them are false. So if in this statement, if I check that F is true, so if I know F is true, then I know B must be false, because there's no way at this point in my code that F and B could both be true, right? Because if F and B were both true, I would have gone in here and returned already. So I already know that B is false. I don't need to even check it. So that part is redundant. It's unnecessary. And same thing there. This is the unnecessary one this time. So yeah, things like that. There are always ways, not always, but there are often ways to shorten your code if you do some thinking. So yeah, that is how we could do this one. Yeah, and I quite like this solution. And in fact, I even like the variables. Usually I have something to pick at with their solutions, but I actually like this one. The Boolean variables make it very clear. All right, given an int in, return the string form of the number followed by exclamation mark. So the int 6 yields 6 exclamation mark, except that the number is divisible by 3, use fizz, 5, use buzz, divisible by both 3 and 5, use fizzBuzz. All right, so let's see. One thing you might need to know before you try this one is that if you want to convert a int to a string, or in fact any primitive type to a string, you can just say string.value of, and then pass in the primitive thing you want to convert to a string. I think we talked about that before, but that's just a reminder. All right, go ahead and pause and try this. Alright, so this one's not difficult to think about, I don't think. It's just kind of a lot of code. So let's go ahead and do this, and let's see, what do we return if it's not divisible by anything? We say just the number with exclamation mark. Okay, we can do that. So let's see here. So I'm gonna split this up. I'm actually gonna do, because I've been so inspired by the previous solution, I'm gonna do booleans f and b. So f is gonna be if in is divisible by 3, and b is gonna be if, sorry, in is divisible by 5. Okay. So now we can say if f and b return. I'm going to return if, I'm going to return fizzBuzz, just fizzBuzz exclamation mark. If f, I'm going to return fizz. If b, I'm going to return buzz. Don't forget the exclamation mark. Otherwise, I'm going to return just the given number, value of in, plus an exclamation mark concatenated at the end. Hopefully you were yelling at me for that semicolon. Okay, so there we go. That's how we could do this one. Now notice that if you ever try to concatenate something that's not a string to a string, so like let's say I didn't do the string.value of, I just try to say in plus the string, it actually will still work. And what it will do is it will basically put in the string.value of part that I just had for you. So in other words, it'll convert the primitive thing to a string, or the non-string thing to a string before it concatenates it. So yeah. And it'll basically be as if you had called string.value of on that thing. So that is how we could do this one. Of course, there are other ways, but we don't have time to go through every single way. All right. Given 3 ints a, b, and c, return true if it is possible to add 2 of the ints to get the third. Go ahead and pause and try this. Okay, so I'm just going to go with the obvious one. I don't think there is really a clever way to do this, so I'm just going to say, just try all the possibilities, basically. If a plus b equals c, or a plus c equals b, or b plus c equals a. Yeah, so I don't think there is really a more clever way to do this. If all the numbers were guaranteed to be positive, which looking at the test cases is true, but given the problem statement, we are not guaranteed that all the ints are positive. If they were all positive, an elegant, or I guess interesting solution that comes to mind is sorting the 3 numbers and then adding the first 2 of the sorted list together and seeing if you get the third. Um, Looking at the code, though, that would probably honestly take longer, or take more code. So yeah, we're just going to go with this solution here because I can't really think of a clever way to do this other than just, here are all the possibilities. Okay, let's go on to the next one. Given 3 ints, a, b, and c, return true if b is greater than a and c is greater than b. However, with the exception that if b okay is true, b does not need to be greater than a. I definitely need to reread this one. Go ahead and pause and try this. Okay, so I'm going to split it up into whether or not b is okay, because I think that just makes it easier to think about, but maybe we can simplify it later. So if b is okay, b does not need to be greater than a. So in other words, the only condition that needs to be satisfied is that c is greater than b. And then if b is not okay, then b has to be greater than a, and c has to be greater than b. Sorry, strictly greater than b. Okay, that is that one. And looking at this, it does look like we can simplify this. So we know that in both cases, there's a common condition, and that's that c has to be greater than b. So what I'm going to say is return true if C is greater than B and either B is greater than A or B is okay. So either so we know C is greater than B has to be true. And I'm saying in addition to that, either B is fine or we don't have to check B, right? So that's basically what this is saying here, and that will do the trick. Given three ins A, B, and C, return true if they are in strict increasing order. However, with the exception that if equal OK is true, equality is allowed, so they have to be in non-decreasing order. Pause and try this one. Okay, so I'm going to split it up, once again, based on the value of equal OK. So if equal is OK, then I'm going to um, return if A is less than or equal to B and B is less than or equal to C. Otherwise, return if um, A is less than B and B is less than C. There you go. Not really much to do here, so I'm honestly just going to leave it like that. Given three ins A, B, and C, return true if two or more of them have the same rightmost digit. This is a crucial thing or like it's not that crucial, but an important thing to know in comp sci is that if you want to get the last digit of a number, you can just mod it by 10, right? Because if you take a number and divide by 10, remainder it by 10. If you take a number and you remainder it by 10, then uh, then your answer will be the last digit of the number. So let's do that. So you need to return true if two or more of them have the same rightmost digit. Yeah, so pause and try this one if you haven't. All right, let's get to it. So two or more of them have the same rightmost digit. Okay, so this one, let's see how we could do this. All right, so the same rightmost digit. Okay, so let's see here. So what I could do is what I'm going to do is I'm going to say if or actually, let's see. I'm actually just going to get the last digits. And in fact, because once I get the last digit, because all I care about these numbers is their last digit, I'm actually just going to reassign them to their last digit. I'm just going to say A equals A mod 10, B equals B mod 10, and C equals C mod 10. So yeah, notice that you can basically use the parameters of your method as if they were variables. So you can reassign to them, right? You can just think of them as variables that already have a value coming in. So yeah, since I only care about the last digit, I'm just going to reassign them here. Okay, so if two or more of them have the same rightmost digit, so how could we figure that out? So let's see. So what I'm going to say is that if A's rightmost digit equals B's rightmost digit, or A's rightmost digit equals C's rightmost digit. So these are two ways in which the in which we could have at least two numbers with the same rightmost digit. Then I'm going to return true. Otherwise, in fact, I can actually combine this all into one if statement. I can say if A and B have the same digit, A and C have the same digit, or C and B have the same digit. So I'll actually write that as B equals C. Then I return true, otherwise return false. Here we go, and of course we could make this a bit simpler here, like that. All right, so as you can see, yeah, doing this simplification at the beginning makes it a lot cleaner by doing these reassignments here. All right, given three ints, return true if one of them is 10 more or less than one of the others. So, and yeah, it looks like exactly 10 more or less than the others. Go ahead and pause and try this. Okay, so let's see. There's quite a few ways to do this, of course. I'm just trying to think of what would be a nice way to do it. I'm going to make a method called diff10, which will return if the difference between the two numbers is exactly 10. So it'll take two numbers, we'll call them A and B, and it's going to return true if their difference is exactly 10. And now all I need to do is return if diff10, if A and B have a difference of exactly 10, or A and C have a difference of exactly 10, diff10, or B and C have a difference of exactly 10. All right, let's see here. This one, let's see, run was false. Okay. So one of them is 10 more or 10 or more. Oh, I think I misread the problem. I read this as 10 more or 10 less than one of the others, but it says return true if one of them is 10 or more less than one of the others. Okay, so reading, good idea, is what we're learning here. Okay, so 10 less than one of the others. So if, let's see, okay. So one way I could do this is I could find the minimum of all the numbers first. I'm going to say min equals math.min, math.min. We've talked about how to find the max or min of three numbers before. So now that I have the smallest of all the numbers, what I'm going to do is I'm going to say, right, because if any number is going to be 10 or more smaller than another number, than any of the others, then that number has got to be, not got to be, but if there is such a number, then the minimum number out of the three will be that number. So the minimum number, if there is a number that's 10 less than another one, the minimum number will be such a number. Okay, so all I need to do is I need to see if min is less than, is 10 or more or less than any of the other ones. So if min is less than or equal to a minus 10, so a minus 10, right? This is 10 less than a, or min is less than or equal to b minus 10, or min is less than or equal to c minus 10. And if those are true, we're going to return true, otherwise false. There we go. Reading the directions. Very wise. All right. There we go. Let's see how they did it. Okay, 10 or more less than the others. Yeah, so looks like they did it, yeah, they did it like this. So they're basically saying that we can do the absolute value thing here because it doesn't matter if A is the smaller one or B is the smaller one. If their difference is greater than or equal to 10, then we know the smaller one is 10 or 10 or more or less than the bigger one, no matter which one's the bigger or smaller one. But yeah, that is another way to do it. I don't really know which one I like better, but yeah, always many ways to do things. Return the sum of two six-sided dice rolls, each in the range 1 to 6. However, if no doubles is true, and the dice show the same value, increment one die to the next value, wrapping around to 1 if its value is 6. Ooh. Okay, pause and try this one. Alright, let's do it. So, I'm going to first handle the no doubles possibility here. So doubles are not allowed. Well, first of all, I'm going to handle the possibility of no doubles and we actually rolled a double, because if no doubles is true, and we didn't roll a double, then I don't really care. So if no doubles is true and we rolled a double, then we need to increment 1 to the next one. And since I know they're equal, since I know die 1 and die 2 are equal, it doesn't matter which one I wrap around. I increment and wrap around. So I'm just going to pick die 1. So all I need to do is say to increment and wrap around is I can just add 1 to die, and then I can say if die now equals 7, because the die definitely should not equal 7, then reset it back down to 1. Die 1 equals 1. And then all I need to do is return, and in fact I can let this fall through here and I can say return die 1 plus die 2. There you go. Now this thing here, I'm trying to think if there's a more clever way of wrapping around here. If it said, if the dice rolls were, instead of being in the range of 1 to 6, they were in the range 0 to 5, we could do something nice here with mod. But I don't really think there is a more elegant way to do this. You could do it with a ternary operator if you wanted to, by saying die 1 equals if die plus 1, if the next number is 7, then its value is 0. Otherwise, it's just the next number. So yeah, putting die 1 would be good. Okay, so yeah, that is another way to do it with the ternary operator. But in my opinion, this is just one mess of a line, and I do not want to read this. So I would leave it as the if statements, or the if statement here, like this. So yeah, and one thing you saw there is that if I have an assignment like x equals, x plus 7, what you can see here, and I'm sure you've noticed this before, is that this part on the right is evaluated using whatever the previous value of x was. So on this line here where my cursor is, whatever value x has at this point is used to determine this, and then this, the result of this, what I've highlighted, is then stored as the new value in x. So that's what's going on there. This part is always evaluated first, is always done first. All right. Max mod 5. Given two int values, return whichever is larger. However, if the two values have the same remainder when divided by 5, then return the smaller. In all cases, if the two values are the same, return 0. Okay, go ahead and pause and try this. All right, so whenever I see something like in all cases, I'm always going to do that first. So if A is B, return 0. And then I'm going to say if they have the same remainder when divided by 5. I think mathematically we would say they are congruent mod 5 would be the mathematical way of saying that. So they have the same remainder when divided by 5. Then we return the smaller value, which we know we should do by doing math.min. Otherwise, we return the larger value. Let's see. What have I done? If they're the same remainder, sorry, that's not what I want to be doing. If they have the same remainder, mod 5, then I return the smaller one, not if one of them is mod 5, or is a multiple of 5. Okay, so yeah, that is how we could do this one here. You have a red lottery ticket showing ints A, B, and C, each of which is 0, 1, or 2. If they are all 2, the result is 10. If they are all the same, the result is 5. Otherwise, so long as both B and C are different from A, the result is 1. Otherwise, the result is 0. Okay, so let's see. If they're all value 2, the result is 10. So if A is 2 and B is 2, I'm basically not going to really talk about this solution very much because it's just typing. It's just translating English to Java pretty much. There's not much thinking that you have to do here. So if they're all the value 2, the result is 10. So if they are all the value 2, the result is 10. Otherwise, if they are all the same, the result is 5. So otherwise, if they are all the same, the result is 5. And next it says, otherwise, so long as both B and C are different from A, the result is 1. So if B is different from A and C is different from A, the result is 1. Otherwise, the result is 0. All right. You have a green lottery ticket. If the numbers are all different, the result is 0. If the numbers are the same, the result is 20. If two of the numbers are the same, the result is 10. So I'm just going to, again, translate English into Java. So if they're all different, A is not B, and B is not C, this is how you could say if they're all different, then the result is 0. If they are all the same, A equals B and B equals C, the result is 20. If two of the numbers are the same, the result is 10. So if A is B or B equals C or uh, A equals C. I usually do it in another order, so I'm going to do it in that order to be consistent. So if A equals B or A equals C or B equals C, then the result is going to be 10. And then, yeah, then that one is, let's see. So what do I do if, yeah, actually, it looks like I don't have another condition, right? Because either, yeah, either they're all different, they're all the same, or exactly two of them are the same. So it looks like, yeah, that those are the only possibilities if you think about it. So, yeah. So let's see. What am I failing here? So this one here is giving me 0. So A is not B and B is not C. Oh yeah, this will actually not check if they're different. We also need to do if A, we need to check all three. So A is not B, A is not C, and B is not C. That's how we would do that one. Okay, a bit of a logical mistake I made there. So yeah, so this is how we could check if all three of them are different. Because what I had before, A is not B and B is not C, fails for something like 1, 2, 1, right? Because in this case, this is not this, 1 is not 2, A is not B, and B is not C, 2 is not 1. But, of course, A and C could still be equal, so I need to check that they are not as well. All right, so there you go. That is how we could solve that. A blue lottery ticket this time. So this makes three pairs, which we'll call A, B, B, C, and AC. Consider the sum of the numbers in each pair. If any pair sums to exactly 10, the result is 10. Otherwise, if the sum is AB is exactly 10 more than either BC or AC that sums, the result is 5. Otherwise, the result is 0. Okay, so gonna just kind of write what it says there, but in Java. So it makes three pairs, A, B, B, C, and AC. So A, B, B, C, and AC. Okay. Consider the sum of the numbers. If any pair sums to 10, the result is 10. So if AB is 10, or BC is 10, or AC is 10, the result is 10. Otherwise, if the AB sum is exactly 10 more than either the BC or AC sum, the result is 5. So if AB is exactly 10 more than BC, or AB is exactly 10 more than AC, the result is 5. Otherwise, the result is 10. Let's see, sorry, sorry, the result is 0. There you go. All right. Given two ints, each in the range 10 to 99, return true if there is a digit that appears in both numbers, such as the 2 in 12 and 23. So you can read the hint or the note if you want. Go ahead and pause and try this. So this is another very useful fact, that if you divide a number by 10 and you're doing int division, that's the same as chopping off the last digit in the int. So that can be useful for this problem. So let's get, basically what I'll do is I'll get the first two digits of A, or the only two digits of A. So the last digit, A last, is going to be just A mod 10, and then A first, the first digit in A, and actually I'll just call these 1 and 2. So A2, the second digit in A, the last digit in A, is going to be A mod 10. And then the first digit in A, A1, is going to be the last digit if I were to chop off the current last digit. So in other words, I did not do a very good job of explaining it, so let me draw it here. So let's say I had like a number like 7, 3, 2, 9. Beautiful handwriting, I know. So if I were to take mod 10 of this number, it would just give me 9, which is the last digit. But if I were to chop off the last digit and then do mod 10, sorry, remainder 10, I would get this digit. And so in other words, if I first divide by 10, chopping off the last digit, and then remainder by 10, it'll give me this digit here, which is what I want. And just if I want to get any digit, I just have to chop off enough of these. I have to keep dividing by 10 enough times until I get to where that digit is the last one in the number. So A1, I'm going to first chop off the last digit, and then mod by 10, remainder by 10. And in fact, now that I think about it, because I know that the ints are in the range 10 to 99, I don't even need to mod 10, right? Or sorry, remainder 10. Because if you divide any number in the range 10 to 99 and you do int division, you divide by 10, the answer will already be in the range 0 to, in fact, actually 1 to 9 inclusive. So I don't even need to mod by 10, because if you take a number in the range 1 to 9 and remainder by 10, then it won't do anything. So I don't even need to remainder by 10 there. Okay, and then I'm going to do B2 and B1 as well. And in fact, I'll actually reverse the order just, because I like things to be in numerical order. So I'm going to do that. So B1 is B over 10, and B2 is B mod 10. And now what I need to do is return true if there is a digit that appears in both numbers. So let's do that. So in order for a digit to appear in both numbers, we could have either A1 equals B1, A1 equals B2, A2 equals B1, or A2 equals B2. So I'm just going to write out all of those possibilities. So I'm going to return if A1 equals B1, or A1 is B2, or A2 is B1, or A2 is B2. And there we go here. And yeah, they did it pretty much the same way. Yeah, basically the same way. Given two non-negative ints, a and b, return their sum so long as the sum has the same number of digits as a. If the sum has more digits than a, just return a without b. You can return, you can read the note if you want to. Go ahead and pause and try this. Alright, so they give you a clever way to find the length of a number, the number of digits in an int, assuming the int is not negative. Notice that the string.value of trick they tell you about would fail for negative numbers. But yeah, we can use that to find the length of the number of digits in a number in base 10. So let's do this. So I'm first going to get their sum. Their sum is going to be a plus b. And then the number of digits in their sum is going to be, if I convert the sum to a string, and then I get the length of that string, that'll be the number of digits in the sum. And then I'm also going to get the length of a. So a length is string dot value of a dot length. And then I'm going to say if sum has more digits than a digits, if sum has more digits than a, then just return a, otherwise return their sum. Okay, so there you have it. That is how we could do this one. If you really wanted to, you could, elide some of these variables if you wanted to. Yeah, I'll just leave it as it is though. We could use ternary if we wanted to. We could do plenty of things if you wanted to. But this solution that I have will be just fine. Alright, so that is the last one. And we are now done with the Logic-1 section. Yeah, sorry if I was a little out of it today. It does get kind of tedious for me, just like basically translating English sentences into Java code. But yeah, that is how we could do that. Again, like I've done these problems a lot of times, so sometimes they do get kind of boring. But it is totally okay because we're about to get into some more harder ones, and for me that means more fun ones down here. So hope you again learned something today, got some practice in, and I'll see you next time for Logic 2.